Hey there, science fans! Today, we're diving into the fascinating world of photonics, the science of light. It's all about how we can generate, control, and use light to do incredible things. From lasers that can cut through steel to holographic images that seem to pop right out of thin air, photonics is changing the world as we know it. Now, you might be wondering, what's so special about light? Well, light is energy, pure and simple, but it's also information. And when we learn to harness that energy and information, we can unlock some truly mind-blowing possibilities. One of the most important breakthroughs in photonics was the invention of the laser. Lasers are like beams of pure light, all lined up and moving in the same direction. This makes them incredibly powerful and precise tools. But before we get into lasers, let's talk about the amazing quantum mechanics that make them possible. Get ready for some spontaneous and stimulated emission. So buckle up, because we're about to embark on an exciting journey into the heart of photonics. Okay, so we know that light is made up of tiny packets of energy called photons. But where do these photons come from? Well, they're actually emitted by atoms. You see, atoms are like little solar systems with electrons orbiting a central nucleus. And just like planets can be in different orbits, electrons can be in different energy levels. Now, sometimes an electron in a high energy level will spontaneously decide to jump down to a lower energy level. When this happens, it releases a photon. That's spontaneous emission. It's like the electron is saying, I've got too much energy, time to let some go. But here's where things get really interesting. If a photon comes along with just the right amount of energy, it can actually stimulate an electron in a high energy level to jump down to a lower one. And when that happens, the atom emits a second photon that's identical to the first one. This is called stimulated emission. Pretty cool, right? Stimulated emission is the key to making lasers work. It's like a chain reaction of photons, all perfectly in sync with each other. Now, we know that stimulated emission can amplify light, but to create a laser, we need a whole lot of stimulated emission happening at once. And for that, we need something called population inversion. Think of it like this. Imagine a stadium full of people. Normally, most people would be sitting down, with only a few standing up. That's like atoms in their ground state, the lowest energy level. But to get a laser going, we need more people standing up than sitting down. We need more atoms in an excited state than in the ground state. That's population inversion. So how do we achieve this? Well, we need to pump energy into the system. This can be done in several ways, like using electricity, light, or even chemical reactions. The important thing is to get those atoms excited and ready to release photons. Once we have population inversion, we're ready to unleash the power of stimulated emission and create a laser beam.
CO2 lasers. A deep dive into construction and operation. Let's take a closer look at the CO2 laser. Known for their high power and efficiency, these lasers are ideal for many applications.
It starts with a sealed tube filled with carbon dioxide, nitrogen, and helium. This gas mixture is the heart of the laser. Electrodes at each end create an electrical discharge.
This excites the nitrogen molecules, bumping them to a higher energy level. They transfer energy to CO2 molecules, exciting them.
This leads to stimulated emission. A photon interacts with an excited CO2 molecule, releasing another photon. These photons bounce between mirrors, creating a powerful laser beam.
Lasers in action, revolutionizing IT, medicine, and industry. Lasers have revolutionized countless industries, from telecommunications to medicine to manufacturing. Let's explore some of the amazing ways lasers are being used to shape our world.
In the world of information technology, lasers are the backbone of fiber optic communication. These tiny beams of light carry vast amounts of data at incredible speeds, enabling us to connect with people and information across the globe. Lasers are also essential for data storage devices like CDs, DVDs, and Blu-ray discs, allowing us to store and access vast libraries of information.
In medicine, lasers are used for everything from correcting vision to treating cancer. Laser eye surgery, such as LASIK, has helped millions of people achieve clearer vision by reshaping the cornea with incredible precision. Lasers are also used in dermatology to treat skin conditions and remove unwanted hair or tattoos.
In the industrial sector, lasers are indispensable tools for cutting, welding, and engraving materials with incredible accuracy and speed. From cutting-edge manufacturing processes to delicate surgical procedures, lasers are pushing the boundaries of what's possible.
Holography capturing light, recreating reality. Let's talk about holography, a technology that records and recreates three-dimensional images using light. Unlike traditional photographs, which only capture light intensity, holograms capture both intensity and phase of light waves, allowing us to recreate a truly three-dimensional image.
To create a hologram, we need a laser beam, a beam splitter, and a recording medium. The laser beam is split into an object beam and a reference beam. The object beam illuminates the object, and the light scattered is recorded on the plate. The reference beam creates an interference pattern with the object beam. This pattern encodes the three-dimensional information.
To view the hologram, we shine a laser through the developed plate. The light diffracts, recreating the original wavefronts. This creates a virtual image that appears to float in space. Holography is used in security, art, and science. As technology advances, expect more innovative uses.